Hi everyone, welcome to the new video of Physics Field. Now in today's video, I'm not here to discuss any kind of experiments. I'm here to clear your doubts. I have seen there are so many doubts regarding the sign convention of mirrors as well as for lens. So as you can see in this diagram, I have just made a small chart where the sign convention of mirrors is discussed. I will discuss the sign conventions of lens as well. At first, let's talk about the concave mirror. In the case of a concave mirror, as you can see that the object distance, the image distance and the focal length, all of them they are negative for 5 cases. Right? What are the cases? Whenever the object is placed at infinity, or suppose the object should be placed beyond of center of curvature. Otherwise, if you are placing the object at the center of curvature or between center of curvature and focus, or if you just place the object at focus as well, every time you are just getting a real and inverted image. But there is only an exceptional cases there. Whenever the object is placed in between of focus and pole, then only you are just getting a virtually magnified image, right? So for that case, the sign conventions are different. Why I am saying that object distance, image distance and focal length, they should be negative for the case of concave mirror, because every distance should be measured from the pole. Whenever you are measuring the distance of the object from the pole, you have to move towards left. So you are in the opposite direction of the incident ray. That's why the distance is considered as negative. If you are measuring the distance in the same direction of the incident ray, then in that case the distance should be positive. If you are measuring the distance in the opposite direction of incident ray, then the distance should be negative. To measure the object distance, to measure the image distance and focal length, every time we have to travel in the left direction from the pole. That's why I'm just taking all of the distances to be negative. Okay. Now let's talk about the exceptional case. In that case, the object is placed in between of the focus and the pole. So obviously there is a virtually magnified image is formed. But the image is formed behind the mirror. So that's why if you just measure the image distance, it is in the same direction of the incident ray. So that's why the image distance in this case is positive. Rest of all, like the object distance and the focal length, they are still negative. This is all about concave mirror. Now let's talk about the convex mirror. The convex mirror is one kind of diverging mirror. So for all of the cases, wherever you are just placing that object, suppose at any point if you just place the object in principal axis, or if you are just placing the object in infinity as well, every time the image will form on the other side. So if you just calculate the image distance in the same direction of incident ray, the image distance should be positive. Where the image is formed in the same side, the focal length should be considered. So that's why the focal length, it is also positive. And the object distance, it is always negative. For all the cases of mirrors, for all the cases of lens, the object distance, it is always negative. Okay, so let's revise. Suppose for the case of concave mirror, for 5 cases, the sign conventions that I have discussed, they are same. Like object distance, image distance and focal length, all of them are negative. But for that special case, whenever the object is placed in between of focus and pole, as you can see in this image, the image distance will be positive, because you are measuring the image distance in the same direction of incident ray. So that's why the image distance I am considering as positive. The object distance still it is negative, the focal length it is still negative. Clear?